All right, we just trained a unit model for nuclei segmentation, so I'm gonna now use this model to segment automatically nuclei in images. So I started by on the same page just to show you what you need to do when you're done with your training. You can close your notebook. Very importantly, you need to shut down your notebook because otherwise, for example, if you start a new training, probably you're gonna run out of memory. So when you're done with a notebook, best practices would be to shut it down the way I just showed you. Now you see it's shut down because it's not highlighted in yellow anymore. So now I can go to running and use my model to segment nuclei. So you see, always organized the same way. So I'm gonna run the first panel to load codes and Python packages we need to process images. And then I'm gonna define the parameters. So first the input directory, so which images I want to segment. So I'm going to use the test where we have all the images, so both confocal and wide field images that were used in the paper. Then I'm going to define which model I want to use. So when I do that, I'm directly in models, and that's the model we just trained. So as you can see, it's been defined with the parameters we used. So one channel, 3 classes, an imaging field 256 to 56, a learning rate of 0.0001, no data augmentation 100 epoch. So I'm going to click on it and select it. Now you see when you select a file, it's in yellow-orange. When you select a folder, it's in green. So that just reminds you, if you want to check if you actually selected the right thing in your parameters. And finally, I'm going to define an output directory for my results. So if I go there, I have these folders for training, this one for test. I don't have an actual folder for the results, so I'm going to define one. So if I open an Explorer, I'm going to go to my GitHub folder, which is in there, in unit, datasets, and nuclei segmentation E2Fs, and I'm going to create a folder for my results. So I'm going to call it results. And now I can select it. So I have a folder which is called results. I select it. So the other parameters we need to define if we want to have the score for each class, or if we want to have the maximum. So at each pixel, so if I let it that way, if I don't check the score box, at each pixel I'm going to have the class that gives the maximum score. So if you do a semantic segmentation, that's perfect, but here it's not really a semantic segmentation. We want to do an instant segmentation, but using a unit. So we will have to still separate the nuclei, and it's useful to have a score. So I'm going to check this box to actually have a score at each pixel for each class. So we have one channel, 3 classes, imaging field 256 by 256. That's the one we used when we trained the model. So all the other parameters are fine. Now I can run everything. And so bunch of warnings again, but it's all good. And I have 6 images, so it's running all the images. You see it's pretty fast. And now I can go to results, and I can open them with Fiji, for example. So as I have the score, I have 32 bits images, so it's open as a with the bio format, but it's fine. I can just open it with OK. And you see we have the three classes. So in red we have the nuclei contours, in green we have the inner nuclei, and in blue we have the background. So you see, if we look at the actual image, if I go to test, it's going to be this one. So it's not going to be perfect, but it seems to be pretty fine. So we see that here, for example, we're going to run into some trouble to separate. We actually have 2 different nuclei here that should be there probably. But at least so we trained the model, and it gives something that makes sense with the data we use to train it. If I open the other results, obviously, if I look at wide field images as this one, it's probably not going to work fine because we only used confocal images to train our model. And yeah, you see, it's really bad. But that's not a surprise. Wide field images are very different from confocal and look, much more complex. So if we only use confocal images in the training, it's not surprising that when we try to process wide field images, it doesn't work that well.